Good day everyone, I am Arman Joseph F. Watco from VSC 2D and today I will explain motion at constant angular acceleration using this example. So let's go. Sample number 1. A disk initially rotating at 3.5 radian per second make 3 complete turns before coming to a stop. A. Calculate its angular acceleration. B. Calculate the time does it take to come to a stop. For letter A, given sa atin yung angular position theta in revolution, ang sabi dito, makes 3 complete turns. And ibig sabihin, 3 revolution o 3 ikot, and then i-convert natin sa radians dahil kapag gagamitin na natin yung equation for angular quantities and the rotational motion under the constant angular acceleration, dapat naka-radians yung position. So we have to convert it to 3 revolution times sa factor na 1 revolution equals to 2 pi radians. And cross out natin yung revolution. So the angular position is now equal to 6 pi radians. To calculate the angular acceleration, gagamitin natin yung equation for the rotational under constant angular acceleration. So, final angular velocity square is equal to initial velocity square plus 2 times alpha, the angular position. So, we have to derive the equation dahil ito yung hinahanap. So, angular acceleration is equal to final velocity square minus initial velocity square over 2 times angular position or the angular displacement. So, by substituting angular acceleration is equal to 0 yung final velocity natin kasi according to stop ito. So nag-stop na siya with the initial velocity na 3.5 radians per second quantity squared. So this is 0 na over 2 tas yung ano natin, yung angular position na 6 pi radian. And by calculating our angular acceleration now is equal to negative 0.3249 radian per second radian per second square. For letter B naman, calculate the time does it take to come to a stop, and gagamitin natin yung first equation. So final angular velocity is equal to initial angular velocity plus angular acceleration times the time. Yeah. Solving for the time, t is equal to final angular velocity minus initial angular velocity over angular acceleration. So substituting the values, t is equal to again 0 na to So 0 minus 3.5 radian per second over negative 0.3249 radians per second square. By calculating, the time now is now equal to 10.773 seconds. So this is example for motion at constant angular acceleration.